Let's now take a look at this next review problem. Suppose that a, b, q, and r are integers, so that a equals bq plus r, shades of the division algorithm. Prove that the greatest common divisor of a and b is equal to the greatest common divisor of r and b. The way that we're going to do this is we're going to show that the greatest common divisor of a and b is less than or equal to the greatest common divisor of r and b, and vice versa. So the left side will be less than or equal to the right side will be less than or equal to the left side, and therefore the two things must be equal to each other. So let d1 be equal to the greatest common divisor of a and b. Then, well, it's a divisor, so that means that d1 divides a and d1 divides b. Okay, so by the theorem we proved in class, d1 must divide a minus b times q. So if d1 divides a and d1 divides b, then if I take a minus a multiple of b, then d1 must also divide that. So notice that d1 divides a minus bq by definition. That means that d1 divides r. So d1 divides b and d1 divides r. So d1 is a common factor of r and b. d1 is a common factor of r and b, so that means that d1 is less than or equal to the greatest common divisor of r and b. d1 is a common divisor, so it must be less than or equal to the greatest common divisor. Okay, that's one direction. Let's now do the other direction. You may want to pause the video now and try it out on yourself. But it's going to be very similar logic. So you might want to pause the video now, try it for yourself, and then restart it to see if you get it right. Okay, let's go the other direction. Let d2 equal the greatest common divisor of r and b. Then, by definition, it's a common divisor, and so d2 divides r, and d2 divides b. So from a theorem that we proved in class, that means that d2 divides b times q plus r, because q is an integer. By definition, that means that d2 divides a, because b times q plus r is equal to a. So therefore, d2 divides a and d2 divides b. So by definition, d2 is a common divisor of a and b. And therefore, that common divisor must be less than or equal to the greatest common divisor of a and b. And remember, that's equal to d1. And the greatest common divisor of r and b, that's by definition, we just said equal to d2. So d1 is less than or equal to d2. d2 is less than or equal to d1. Therefore, d1 is equal to d2, or the greatest common divisor of a and b is equal to the greatest common divisor of r and b. And that's the end of the proof.